So we exit the editor. We're going to follow the instructions on this guide. Well, we build the first machine. We're going to compile it. For that, we need the scheduler. So we're going to follow these steps here. You might a workspace. If it already exists, I'm going to remove it so that you see I make everything from the beginning. Inside a workspace, I'm going to make a source directory where the packages are going to be. We also going to download the scheduler from the same page here. I'm going to go to my downloads, untap package it to make sure that everything is clean. Now I extract, and I'm going to go to the workspace that I move from the workspace, and I move it into source. Move package from a workspace to another workspace. It has to go from the source to the source. The same for clfsm. Check our source directory. We're gonna build live clfsm. Repeat the instruction here, but just building clfsm. Now in install lib clfsm lib, you see the library, and also we should see the executable. So now I'm going to go into source and create a package for the machine. Notice that it's a large command. You'll see now you have an extra package here. If we go back to the history, the dependencies are here. These machines are already built for you. The machines are here. I'm taking the machines here because I want to bring this script. We're going to go again for a moment to download. Again, these machines are already all built for you. If you look, here is the script we are after. If you look at the source, they are all the demo machines as packages. With MiEdit, we only build this. I'm going to go back where we're building everything. I'm going to go to the package of the machine. The first thing is I'm going to make a directory called machine. Into that directory, I'm going to copy the script inside machine. My machine was built in here, so I'm going to move it and put it also in the directory machine. Now, if you go into machine, we have the machine itself. The machine is nothing more than a bunch of files that you can see here. I'm going to run the script with the machine. It builds a suggested file. In our case, the suggested CMake file is going to replace the CMake. Go all the level up to build trust to ping pong. If you get an error like happened here, it could be that you need to scroll back and find the error. We found it here. I'll tell you two tricks very quickly. You can edit the CMake list and take rid of these 3 lines. Build again. It's much easier to find the error. The second part is to notice that this error is in the onEntry section of a state. You can edit your machine with the editor, or sometimes here is much easier to go directly to the machine. The file that constitutes the state and is on entry section, and we have a simple C++ error we do need to run the split again. We need to go to source, to ping pong machine. Now this was not a structural change. We don't need to copy back the CMake file. Now sometimes it's easier to have several terminals to do this. And we build again. The machine has successfully built. You can check that by looking in install, the name of the package, and here you see this. Check the instructions of why this folder has been built. Now I'm gonna go to another terminal because ROS recommends not to run in the same terminal as we compile. So the first thing I'm gonna do is move the compiled machine as a library into the file and folder that just show you. It should be exactly the same name without, then like in any ROS situation, we run the setup bash so that now we can do ROS to run CLFSM. I'm going to use the option -v to show you the machine is running, and now the path to the machine. And you see the machine here publishing. Just use Ctrl+C to stop it. Let me remind you that the machines already exist in here. We don't have to build them, but now we're going to work with this machine. This machine has a large initial state. One is going to publish is twist messages to move the turtle boat around. So we're going to build this machine again. It actually exists as this folder that you see here. But for completeness, we're going to build them from the beginning. So we invoke the editor. We're going to make a new machine. In this directory, we're going to give it the same name. Let's look at the includes folder, basically the ROS infrastructure, the messages and macros of CLFSM to wait for seconds or milliseconds. We need to add the variables. Now we need to put the content of the initial state. If your initial state is a bit too big or any state is a big in content, you can scroll here, or you can make save. We're going to add a straight state. We issue into the topic that makes the turtlesim go straight. We're going to add a straight to turn right. Add a state just called end. Go back to initial because we're going to make our transitions. We're going to add them always to the end state. That takes care of initial. We're going to go to straight. We're going to add a transition to end. That takes care of straight. We're going to turn right. Then turn right. We also add a transition to end. Now, if we look at our machine, we only need transitions here, here, and here to jump between these two. So let's go back to initial. From initial, we add a transition to go straight. This is executed only if the previous transition evaluates to false. Then we go from straight to turn right. This is the current state to turn right. Then from the state turn right back to straight. Okay, that's our machine. We save and we run this machine. Remember, we were working here. Go inside source. We only have one machine, the first one we started, and now we're going to create the package for the second machine. It's important that you complete all the dependencies, because if we go now into this machine, look at the package, the dependencies get encoded here, and they will be used to split the sources and the header files and to create the corresponding dependencies for compilation. Remember that every time we create a package for a machine, we should create a directory called machine. We should copy the script that splits here. Sorry, this should go inside the directory machine. And then I'm also going to move the machine I just constructed. Also going to put it inside machine. Go inside, and I have my constructor of compilation and my machine builds the corresponding suggestion for CMake list. Copy that suggestion into the CMake list. Back up all the way to the root of the package, and we build. If everything well, our machine is here. Now remember that I run them in another tab. We're gonna start from the top. It's good to run the setup bash every time we're going to use ROS. Now we move the current new machine we have compiled from its lib status into its machine in the corresponding version of Linux. Remember that we copy the library, the moving it, without the lib prefix. I'm going to open another terminal just to run the turtlebot. ROS2 run or clfsm. We just run the machine, and we should observe here the control over the turtle simulator. Now we're going to show how to run the third machine of the demo machines for clfsm. This machine will control the turtlesim so it doesn't hit the wall. It needs a sensor because logically finite-state machines do not enact callbacks. They are a single thread. We download this. We open another one. We're going to go to download. As usual, unpack it. This is a simple piece of software that listens to the topic of the turtlesim and publishes the post. So we're going to go into it. You see what we have in the source. In ROS2, the interface goes in a different package. We're going to build them. Here in order, it's important to build interface first, and then to build the wrapper for the sensor. Now I'm gonna exit this and then open another one just because of ROS2 likes that. We're in download and we built here already, but here is where we're gonna install. So now I can run it. This node doesn't tell us anything. So we go to the screen where we run the simulator. Now to make it move, we had our machine from the previous time. So if we go here, this is moving and have another terminal. This service now exists. I'm going to ask information about it. It gives me the type of the interface, and now I'm going to call it. If you get an error like this, it's because I forgot to do that. Now the position was at 6.1. That's where the turtle is moving somewhere. If I call for this, the turtle is at a different position. Execute now the third machine. I'm not going to build it. We're just going to copy it over. I'm gonna move from downloads the machine ROS to wall. I'm in my source, so I'm gonna move it here. We have the third machine. Go into it. The machine is in here. Go inside. And again, I'm gonna copy from a sister machine that we have used already the script to set up the CMake file. So now I can get a suggested CMake list, copy that suggested CMake list. I'm gonna go to downloads in this package, and I'm gonna source install setup bash so that it finds the interface when it compiles. Remember that this machine depends on the packages of the turtle sensor poster. So to build, we use our build command and the name of the package. Let's check that we have built it as it's here. Now we need several things to run this machine. First one, we're gonna need the turtle set from the beginner's tutorials. We're gonna need our sensor. That one is in download turtle sensor poster. We need to install here, and then we can say ROS to run turtle sensor poster, turtle sensor now. Get this one also going. Definitely want this one to run. So source install setup bash to move this file, move into the file for the machine, the corresponding Linux version. So now ROS to run on the machine. And you get to see the machine reacts to getting too close to the edge. As long as it's away from the edge, it goes straight. If it gets too close, it backs up for a bit and gives a little turn.